everyone, we're going to evaluate the limit as n approaches infinity of 1 divided by n squared times the sum from L equals 1 to n of L e to the power of L divided by n. So basically L for us is our index number, and I want to write this using this formula here. We want to make it look like this left-hand side. It almost does. And then we can integrate it to find the limit. So basically, for us, L divided by n is going to equal x according to our formula. If I rewrite this, I'm going to write this as the limit as n approaches infinity. I'm going to move this inside. So I'm going to write this as, and I have a L here. So I'm going to write this as the sum from L equals 1 to n, and then we have L divided by n. I'm going to pull out a 1 over n later. Then we have e to the power of L divided by n, and then we still have this times 1 divided by n. Now it has this format where everywhere there's a L divided by n, that's going to be an x, and this part's just part of the formula. So now I can write this as the integral from 0 to 1 of x times e to the power of x dx. So it's a nice formula to know. We're going to have to use integration by parts, or you can use tabular integration. Let's use tabular integration. So when you use tabular integration, that means you take your algebraic function and you're going to take the derivative, and then you take your other function and you're going to integrate. So derivative of x is 1, and you keep going down until you get to 0. Derivative of 1 is 0. And then when you integrate e to the power of x, you just get e to the power of x. Then you do these diagonals like that. The first one's going to be plus, second one's going to be negative. So if I just take the indefinite integral of x times e to the power of x dx, that's just going to give me x times e to the power of x minus e to the power of x plus c. All right. If I want to put back the limits, I would go 0 to 1 and take away the c, and then we would evaluate this from 0 to 1. All right, so let's do that. We have x times e to the power of x minus e to the power of x from 0 to 1. So when you substitute 1, you're going to get 1 times e, that's just going to be e to the power of 1 minus e to the power of 1. And then for 0, this one, substituting 0, you're just going to get 0 minus e to the power of 0. E to the power of 0 is just 1. This is 0, so basically we have 0 minus 0 plus 1. Because two negatives here make a positive, so our answer is 1. And that's it. Thank you. Have a nice day. Bye-bye.